Hi everyone, it's Matt with AUB. Moving toward the frame of first year. My first question is find the 20 terms of the series log 2 plus log 4 plus log 8 plus log 16 means log of 2 to the base 10, log of 4 to the base 8 and so on. It's some sort of blend of log and GP, log of geometric progression. If the terms are connected by positive or negative symbol, it is known as series. We have given a series. We are asked to find its 20th term. We are asked to find 20th term. Let me write the sequence series for you as log 2. I write instead of log lg, lg2, lg4, lg8, lg16 and 3 dot to show continuity. Look, our first step must be make or break. 4 can be written as 2 square, 8 can be written as 2 cube, lg4 can be written as 2 raised 4. It's our first term, log of 2 to the base 10 power 1. It's 2 square, 3 square and so on. We can easily determine the value of 20th term is log 2 raised 20. Log 2 raised 20. It's our 20th term. It's our 20th term. If you look at the options, that is not the case. Still, some property of log has been utilized here. We are familiar. Power can be converted to coefficient by virtue of log. It can be written as 10 times log 20th term. We are asked to find 20 terms. Sorry, it must be 2 raised 20. 2 raised 20. 2 raised 20. 20th term. So it is power can be converted to coefficient. It is 20 log 2. 20 log 2. 20 log 2 is our right option in that case. I have determined 10th. I thought it is 10. It is 20 term. That is log 20. Log 20. Our series, our sequence can be written as this one. This question might be asked. Domain of a sequence is always natural number or set of natural number. Domain of a sequence is always natural number or any subset of natural number starting from 1, 2, 3 and so on. Their range might be a real any number, rational, irrational, integer or not. Domain must be natural number or any subset of natural number or any subset of natural number. Here, first time we have log 2 plus log 4 plus log 8 and so on. Just utilize this 2, 4, 8, 16 and so on. They are all powers of 2. I have written 2 raised 1. 4 can be written as 2 square, 8 can be written as 2 cube, 16 can be written as 2 power 4. Now we can easily guess what is our 20th term. Log 2 raised 20. 2 raised 20. I have taken log 2 raised 20. That is our 20th term. If we have a look at the options, that is not the case. We are familiar. Power can be converted into coefficient by virtue of log property. There are 3 humongous properties of log to be kept in mind. Log A, B, C. Multiplication can be converted into positive addition by giving separate logs. Log A, B, C can be written as log A plus log B plus log C. Number 1. Number 2. Division can be converted into subtraction by giving individual logs. Log A minus log B, and the third one is power can be turned to coefficient. LGA raised B can be written as B times LGA. B times LGA. Similarly, power coefficient can be converted to power. Power can be converted to coefficient. Coefficient can be converted. These are the 3 properties of log. We have utilized that one. Power can be converted into coefficient. Moving towards next question. Next question. That is, we have given my favorite one. I have done this question several times. I like it. 1 plus 3 plus 5 dash 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 up to n terms and divided by 2 plus 4 plus 6 means even natural numbers up to n terms is equal to 0.95. Find the log. 1 plus 3 plus 5 and so on up to n terms. Overall 2 plus 4 plus 6 dash 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 up to n terms is equal to 0.95. Sum of odd numbers or natural numbers. Sum of odd natural numbers is given by n square, while sum of even natural numbers is n square plus n is equal to 0.95. It's really very cool. N square is taking n common from the denominator, we have n plus 1. Utilizing tiny arithmetic, 0.95 can be written as 95 over 1 with double zero. 95 over 100. N cancel. We have n over n plus 1. 95 over 100. Cross multiply. 100 times n is equal to 95 times n plus 1. Okay, cool. 100 times n, multiply 95 through 95 n, 95 into 1, 95. Solve for n. Shift quantity like terms on the left hand side. 100n minus 95n is equal to 95. 100 minus 95 minus 5n is equal to 95. Dividing with 5, solving for n, we have 5n is equal to 95 divided by 5. We have n is equal to 19. We have n is equal to 19. We have n is equal to 19. N is equal to 19. Let me write clear. So that's our option. That's our option. One must be familiar what is the sum of odd numbers, even numbers, as well as you are familiar what is sum of natural numbers and so on. Let me write sum of natural numbers for you. There is no space, otherwise I would have written the sum of cubes and so on. In any frame, we will discuss this thing later. Sum of odd numbers is given by n square, while sum of even numbers is given by n square plus n. Sum of natural numbers is n times n plus 1 over 2. Okay, cool. Moving towards next question. 5 raised 1 over 2 times 5 raised 1 over 4, 5 raised 1 over 8 and so on. Find its sum. A little inspection, a little manipulation gives us a fair idea. This is sum to infinity formula for GP. How? Let's see. 5 raised 1 over 2 times 5 raised 1 over 4, 5 raised 1 over 8, 1 over 8 and so on. Bases are same, they are in multi-application at the powers. Right, base 1 times we have 1 over 2 plus 5 raised 1 over 2 plus 1 over 4 plus 1 over 8 and so on. Look at this. If we have a look at the power here, these are all powers of 2. 1 over 2, 4 means 2 square, 8 means 2 cube and so on. From this we can easily deduce that it's a GP sum to infinity where A is 1, R is also 1 over 2. A is 1 over 2, R is also 1 over 2. Here A is equal to 1 over 2, the first term. The second term we are multiplying R. How to find R? A2 divided by A1. What is A2? A2 is 1 over 2 square divided by 1 over 2. R is equal to 1 over 2 square, 2 over 2 to cancel out. We have R is equal to 1 upon 2. One can also find R by taking any two consecutive terms, dividing the preceding one with the upcoming. Look at, take any two consecutive terms. Let me give you a good idea about this. A2 divided by A1. Second term divided by R is equal to A3 upon A2. Taking any two consecutive terms, dividing the latter one with the first one. R can be written as A4 over A3. R can be written as A5 over A4 and so on. Take any two consecutive terms, divide the latter one with the first one. Okay. One can manage. R is this sum to infinity. 5 raised A over 1 minus R. 5 raised A over 1 minus R. A is 1 over 2. R is also 1 over 2. 1 minus 1 upon 2. It will give us 5 raised 1 over 2 over 1 over 2. Cancelled out. We have 5 raised 1. 5 raised 1 is our answer in that case. 5 raised 1 is our answer in that case. Sum to infinity. Sum to infinity formula. Sum to infinity formula is valid when common ratio is less than 1. When common ratio is less than 1. And in that case it is. We can find R from anywhere taking two consecutive terms, A2 A1, A3 over A2, A4 over A3 and so on. Dividing the latter one with the first one, taking any two consecutive terms, not giving gap. So R is equal to 5 in that case. A good question always present in, you can say, at ECAT as well as in quantitative mathematics question. Quantitative type mathematics. We have given the area of a square is 32. Everybody is familiar what is a square. A special case of rectangle having each side equal and every angle is of 90. 32. Here we have its x, x, it's given to us, it's a square. Having area 32. 32, we are asked to find diagonal. We are asked to find diagonal, either this or this, they both are same. area is given by x square, it is equal to 32. Taking root to get x, x is equal to x square root 32, root of 32, x is equal to 32 can be written as 2 into 2 into 2 into 16, 2 to the 4, 4 to the 8 is 16, 32, pair of 2, another 2, x is equal to 2 times under root 2, means we have x is equal to 4 under root 2, x is equal to 4 under root 2, okay. Now our x is 4 under root 2, this is also 4 under root 2, this is also 4 under root 2, angle is of 90, angle is of 90, taking this portion, this lower triangle or upper, it is same, 4 under root 2, that's our 4 under root 2. That's right, it is our hypotenuse. From triangle point of view, it is hypotenuse. If we have a look, if we have a glimpse in the figure of a square, it's our diagonal. Diagonal. It's from right angle triangle point of view, it is hypotenuse, and from square point of view, it is diagonal. Both are same. Solving for hypotenuse means diagonal. Applying Pythagoras theorem, we have h square is equal to b square plus p square. H square means diagonal square, 4 root 2 square plus 4 root 2 square. Square of 4 is 16, square of root 2 is only 2, 16 square of root 2 is only 2, it will become 32 plus 32, so hypotenuse or d square is equal to 64, 32 plus 32, 64. We are asked to find diagonal. Diagonal square is equal to 64, taking root, or diagonal square is equal to 64. Diagonal is equal to 8. Diagonal is equal to 8. There is another good question, always present, mostly present in quantitative mathematics. If diagonal of a square is given, find its area. Let me give you a good hack about this. Suppose we have given same square. We have just found what is diagonal, that is its diagonal. How to find its area? When diagonal is given, area of a square is given by area of a square. Let me manage this piece. Diagonal square divided by 2. Diagonal square divided by 2. What is our diagonal? That's 8 square over 2. Means 64 divided by 2, that's 32. The 32. That's also a question of quantitative mathematics. When we have given diagonal, we can easily find its area. Okay, cool. Moving towards the fifth question, a determinant sort of question. It is a determinant of, I think, 5 by 5. 5 by 5. The lengthy the diagonal or a matrix, the easier is their solution. The lengthy the order of diagonal of determinant, order of determinant and matrix, the simpler is their solution. Look at this. May I write this? Okay. It is going to take time. Minus 2. 4 times. Okay. Let me manage. Then 9 minus 1. Means 0. 2, 1, 3. Then minus 1. 4, 2, 2, 0. The next one is 7 minus 2. 3, 5, 5. Okay, cool. Look at this. It's a lower triangular matrix. These are our diagonal elements. These are our diagonal elements. How to find diagonal? First row, first column. Look at their position. First row, first column. The second row, second column. Third row, third column. Fourth row, fourth column. Fifth row, fifth column. The diagonal element. The diagonal element. Their general notation is given by Aij, where I is equal to G. Where I is equal to G. These are diagonal elements. Diagonal. Lower triangular matrix. Below the diagonal, their elements are non-zero. And above the diagonal, they are all zero. They are all zero. They are all zero. It is lower triangular matrix. Lower triangular matrix. It is sad information. We are asked to find its determinants. It is really very cool. Whether it is upper triangular matrix or lower triangular matrix. Where it is upper triangular matrix or lower triangular matrix or both. Upper triangular, lower triangular matrix or upper triangular matrix or both. Just multiply the main diagonal elements. It's your determinant. Minus 2 times minus 1 times 3 times 2 times 5. Minus minus plus it will become 2 3 the 6 6 4 6 2 5 the 10 60. So 60 is our answer in that case. Look at the lower triangular matrix, multiply the main diagonal elements, first to first column and so on. Lower triangular matrix, multiply main diagonals. Upper triangular matrix, multiply main diagonal elements. If it is both upper as well as lower, means reduced row echelon. If it is in reduced row echelon like this, A 0 0 0 B 0 0 0 C, both upper triangular matrix as well as lower triangular matrix, just multiply the main diagonal. It's your answer. A times B times C, A, B, C. I have already told you, I have already shared with you, the longer the order of determinant and matrix, the easier their solution, the easier is their solution. So 60 is the right option in that case. It's my tiny effort in connection of first year MCQ, mostly selected from where? I have no idea, from any book of ECAT or Aga Khan. Sorry, Anis Hussain past papers from NED, manual of any Anis Hussain, the old one, the good one, having number of questions, many scores of questions. They are now seems to be scarce, not present here and there. Good one, good. Let me these sorts of Anis Hussain. They used to publish such type of manuals. Now they have decreased their size to that and they have compromised on quality. I have selected this from an old manual. Old is good. Okay, it's all bad stuff. Next.